Okay, students, welcome to video class 46. And in this video, we are going to continue our discussion on the state space representation of transfer function. Okay, in the last video, we have seen that the transfer function can be classified according to the terms present in the numerator as p of s to be a constant, as in this example, and we have seen how to obtain the state model from a given transfer function like this. Now you can have another transfer function of the form where p of s can be a polynomial of the form s plus 1 and s squared plus 3s plus 1. In order to get the state model, the approach is quite different, and that is what we are going to study under this video. Okay. Okay, so to understand this, consider a transfer function given by, and we know that transfer function is represented by y of s by u of s that I have explained in the previous video. So again, just for a recap, we know that in the state model, we represent the input by u, the state by x, and by the letter x, and y being the output. So when you consider the transfer function of such a system, it will be y of s to u of s, and let the y of s be say some k into c2s plus c1. Okay, so this divided by sq plus a3 square plus a2s plus a1. Okay, let this be the transfer function. Now this transfer function is of the form where p of s is, the speciality of this transfer function is the p of s is actually what? P of s is a polynomial. It is not a constant. Okay, it is a polynomial. Okay, now you can you can consider this, you can decompose this transfer function as say uh, say say you can consider this as okay, you can represent this as say y of s to u of s by u of s as a product of two polynomials, say constant divided by a square plus eaq plus s square a2s plus a1 all into c2s plus c1, right? I can represent this in this way. Now this is a part of a transfer function, this is also a part of a transfer function. Okay, so I am calling this part as say some x of s as x of s by u of s. Okay, and this one as say some y of s by x of s. Okay, so when you multiply this, what you're going to get is you will be getting y of s to u of s. Okay, so what you need to do is you need to separate this polynomial as a separate transfer function, and the rest has to be considered as another part of a transfer function. So this is actually the product of two transfer function where x of s is just a s variable in s or a function in s domain which we have just put, okay, which we have just assumed, so that on multiplying this x of s get cancelled and you will going to get y of s. So what the idea is to break up the given in such a way that constant by into a transfer function with a constant p of s, and the transfer function with the polynomial has to be separated like this, and calling this as y of s and this as x of s by u of s, this is y of s by u of s. Okay, now you need to do like this. Say consider this x of s to u of s as k by s square plus a3 s square plus a2 s plus a1. Okay, so this is just just like the problem that we have done previously. So you can have a cross multiplication here. So this is x of s into s square plus a3 s square plus a2 s plus a1, right, which is equal to k into u of s, right? Okay, now from this you can find out so this will be equal to s square into x of s plus, this is just as we have done yesterday, s square into x of s plus a2 into s into x of s plus a1 into x of s is equal to k into u of s, right? So next is, now what is the next step? Finding out the inverse Laplace transform. Now keep in mind this is a transfer function, so there is no need of any mm, initial conditions. So this will be so if this is x of s, let us consider the x of the time domain of that x of s to be x of t. Okay, so or let us assume the Laplace transform of x of t to be x of s, so that you can write this equation as d square x of t by dt square, right, plus a3 into d square this is s square, right? Sorry, this is s cube. This is s cube. Sorry. So this will be s cube. So this is d cube by dt cube. This is d square x of t by dt square plus this is s cube, right? Okay. So do this correction. This is s cube, and this will be a2 into dx of t by dt plus a1 into x of t is equal to k into u of t. Okay, so from this what you need to do is you can assume this x of t to be a variable x1, right? And this is one of the state variable, and what must be this dx of t by dt? Dx of t by dt will be x1 dot, or yeah, x1 dot of t. X of t is equal to x1 x1 dot of t, right? And this has to be assigned to be x2. And how many state variables it will be having? It will be having 3 state variables. So the next one will be dx square by dt square, which is actually x2 dot, and you can assign that as x3. Now you will be getting x3 dot from this equation as, okay, this is a3, you can substitute a1 x of t as x1, so this will be minus a1 x1, right? What about a2 dx of t by dt? That is x2, so that is minus a2 x2 and minus a3 x3, then you have a plus k into u of t plus k into u of t, right? So this is your x3 dot. So that means we got the 3 set of state equation, that is x1 dot is equal to x2, x2 dot is equal to x3, and x3 dot is equal to, okay, now you can convert this into matrix. You can convert this into matrix as, okay, as the matrix will be x1 dot, x2 dot, and x3 dot. This is equal to, this is, since there are 3 variables, this is going to be 3 into 3 matrix with x1, x2, x3, right? Now what must be that? This will be, so look at this, x1 dot is actually, what is x1 dot is x2. So this will be 0, 1, 0. Okay, almost in every problem the pattern will be the same. Now x3 dot will be, and this is actually the canonical form and we have already studied. So this will be minus a1, minus a2 and minus a3 plus, what about the next thing? So you have k into u of t. So this will be, so for x1 dot you don't have any u2, u of t, x2 dot also you don't have any u of t. Only for x3 dot you have k. So this will be 0, 0, k into u of t. So this is actually the state equation, right? This is the state equation. So state equation you will be getting from the normal, a transfer function with the constant polynomial, and you need to consider this as separately. Now what about this C2 y2s? Now considering, for finding out the output equation, what you do is you will be considering the polynomial p of s as again a transfer function y of s is equal to c2s plus c1, right? Okay, or this becomes y of s is equal to c2 s into x of s plus c1 x of s. Okay, now taking the inverse Laplace transform, you will get this as y of s, y of t is equal to c2 into dx of t by dt, right, plus c1 into x of t. Okay, now what is your x of t? X of t is assigned to be x1, so you can substitute that y of t as equal to what is dx of t by dt? We have already defined dx of t by dt as x2, so you can replace this by the state variable x2 plus c1 into x1, right? So what's going to be your output? Your y of t will be equal to what? You have c1, c2, 0, right? With the x1, x2, x3, right? So there is no x3 component in y of t. So this is it. So this is your output equation. Okay. So the difference between the previous one is, what you need to do is you need to take the constant polynomial as one of the transfer function. You need to break the transfer function in such a way that, consider this as in this example, k by the numerator has to be considered as a transfer function with the constant p of s, and the p of s, the polynomial part, has to be considered as another transfer function of the form y of s to x of s. So from this x of s to u of s, you will be getting the state equation as we have seen here, and while from the second polynomial, that is from y of s to x of s, you will be getting the output equation. Okay, hope things are clear. Okay, now let's do a question. Obtain the state model of a transfer function given by y of s by u of s into is equal to 10s plus 40 divided by s into s plus 1 into s plus 3. So this is actually equal to 1 into, so this can be disintegrated as or decomposed as 1 by s into, now what is this s into s plus 1 into s plus 3? So what you will be getting it as okay, so this can be written as so this will be s cube plus 4s plus 4s square plus 3s, right? So this is 1 by s cube plus 4s square plus 3s. This can be simplified as into 10s plus 40. Okay, right? Don't try to take any constant from this, just write as such. Okay, so this is usually, even though we have written k, this will be always, will be always equal to 1, right? So you should not take anything common from this. This should be 1 by s cube. Okay, so that means now you can consider this one as what? This one as your y of x of s to u of s transfer function, while this can be considered as the y of s to x of s transfer function. So you need to consider separately this for the state equation, this for the output equation, and both forms the state model. Okay, now let me tell you. So let's start with x of s to u of s. What is x of s by u of s? X of s by u of s is actually equal to 1 by s cube plus 4s square plus 3s, or it is equal to x of s is equal to s cube into, right, s cube into x of s plus 4s square into x of s, right, plus 3s into x of s is equal to u of s. Now when you take the inverse Laplace transform, you will get this as d square x of t, d square x of t by dt square plus 4 times this is d cube, this is d cube, right, 4 times d square x of t by dt square plus 3 times dx of t by dt is equal to u of t, right? Now what you need to do is you need to assume this x of t to be one of the state variables. So how many state variables it will be having? It will be having 3 state variables, x1. Okay, so x of t has to be considered as your x of y, right? We'll come to that. Okay, now what you need to do is you need to assume your x of t to be your first state variable x1. So that means your dx of t by dt, or that is your x1 dot, which is equal to x2. So this is the first of the state equation. Then you have d square x by dt square, which turns out to be x2 dot, or this is x3, that is your second, and you will be getting x3 dot from the equation. So this is x3 dot plus 4 times what is d square x by dt square, which is 3x3 plus 3 into 3 times dx of t by dt, and what is that? That is x2. 3 into x2 is equal to u of t, right? Or you can find out this x3 dot from this as minus 3x2 minus 4x3 plus u of t. Okay, so this forms your third state equation. Now you can have the matrix representation x1 dot, x2 dot, x3 dot, right? So this matrix, this is a 3 into 1 matrix. So you have 3 state variables as expected, x1, x2, x3, right? And upon filling, the first term will be 0, right? x1 dot is actually x2, so this is 1, this is 0, and x2 dot, this is 0, 0, and 1. While filling x3 dot, you don't have any x1 component here, so this is 0, while this one is minus 3, this one is minus 4, plus you have no u of t here, so this will be 0, this will be 0, and this will be 1 into u of t. Okay, so this is actually your state equation. Now how to find out the y of t? Y of t will be obtained from the y of t will be obtained from the next thing, that is from y of s by x of s is actually equal to 10s plus 40, right? It is 10s plus 40, or y of s is equal to 10s into x of s plus 40 into x of s. Taking the inverse, you will get this as y of t is equal to 10 times d square dx of t by dt plus 40 into x of t, right? Now we have already assigned these values, that is dx of t by dt can be assigned as x2, so this is 10 into x2 plus 40 times x1. 40 times x1 is equal to y of t. So your output expression becomes y of t is equal to what? Y of t equal to this is x1, so you can x1, x2, x3, this must be the form. So this will be, what is the coefficient of x1? It is 40. x2's coefficient is 10. x3 is 0. 40, 10 and 0. So this is actually your output equation. Okay. Okay, so next question is, obtain the state model of the system whose transfer function is given by 2 into s plus 5 by s plus 2 into s plus 3 into s plus 4. So this is actually your y of s to u of s. Now we want to split up it into, as shown, as x of s by u of s into y of s by x of s. So for that, what you do is, you should not consider this as the coefficient. You need to multiply, then only it will become of the form c1s plus c2. So in that form, that is, I want to get that in that form as y of s by u of s can be written as 1 by, on expanding this you will get this as s cube plus 9s square plus 26s plus 24, 26s plus 24 into 2s plus 10. Okay, so this 2, you should not consider this as the, this has to be always 1, even though I have shown it as k, that has to be considered as 1. This you need to multiply through to this, then only it becomes c1s plus c2 form. So this is 2s plus 10. Now you can consider this as y of s, so this will be your y of x of s by u of s, right? And this will be your y of s to x of s, right? So now taking the first one, that is x of s by u of s, from this you will get the state equation as 1 by s cube plus 9s square plus 26s plus 24. Okay, so when you do that, you will get this as x of s into s cube plus x cube plus 9s square into x of s plus 26s into x of s plus 24 into x of s is equal to u of s. Okay, now from this, taking the inverse Laplace transform, you will get this as d square x of t d cube x of t by dt cube plus 9 into d square x of t by dt square plus 26 into dx of t by dt plus 24 into x of t is equal to u of t, right? Now from this, what you need to do is, you need to assign the, so x of t is to be assigned as one of the state variable x1. So if that is the case, how many state, you will be having 3 state variables. So then dx of t by dt can be assigned as x1 dot, or that is to be assigned as x2. D square x of t by dt square will be equal to x2 dot or that is assumed to be x3. So from this equation you will get this x3 dot plus 9 into d square, 9 into d square, or that is 9x3 plus 26x2 plus 24x1 is equal to u of t, right? Or your x3 dot becomes equal to minus 24x1 minus 26x2 minus 9x3 plus u of t. Okay, so you got the three sets of state equation. This is another one, and this one is the third. Now converting this into x1 into state equation as x2 dot and x3 dot, this is equal to, okay, this is equal to x1, x2 and x3. Okay, now x1 dot is equal to 0, this is 1 0, x2 dot is 0 0 and 1, and x3 dot is minus 24 minus 26 and minus 9 plus then you have right, so u of t and the first two equation it will be 0, and finally it will be having 1. So this is your state equation. Now from how will you get the output equation? Output equation you will be getting from y of s to x of s is equal to 2s plus 10. Okay, now cross multiplying that. So when you cross multiply that, y of s is equal to 2s into x of s plus 10 into x of s, right? Or taking the inverse Laplace transform, you will be getting y of t is equal to 2 into dx of t by dt, right? Plus 10 into x of t, right? Or what is this 2 into dx of t by dt? Dx of t by dt can be written as 2 into x2 plus 10 into x1, right? Is equal to y of t, right? So your y of t can be expressed as, so your y of t will be equal to, what's that? So this will be, your y of t matrix will be equal to 10 2 0, 10 2 and 0, x1 x2 x3, because there is no x3 component over here. So this is 10 2 0 x1 x2 x3. So this is your output equation, and this forms the state model. Okay.